Fireproof balloon experiment. Why doesn't it pop? Amazing heat physics. What if I told you there's a way to hold a balloon directly over a flame, and it sounds impossible, right? But today we're going to do exactly that, and in the process uncover some incredible physics that explains why some materials can resist extreme heat while others vanish instantly. What's the secret? And how can something as fragile as a balloon survive fire? Let's dive in. Introduction to the science. Balloons are delicate. Just a tiny prick or a bit of heat makes them burst. But with a simple twist, we can make one practically fireproof. The key lies in heat transfer and the unusual properties of water. You see, when most materials are heated, energy flows into them rapidly, breaking bonds and causing damage, like melting or popping. But water is special. It absorbs a massive amount of heat before it changes temperature, thanks to its high specific heat capacity. By using water as a shield, we can protect the balloon's rubber from overheating. But how? Let's test it. Step-by-step experiment. Here's how you can try this safely at home. 1. Gather materials. You'll need 2 balloons, water, and a candle lighter. 2. Inflate the first balloon. Normal. And this is our control. Hold it near the flame. And as expected. 3. Now the magic. Fill the second balloon with a small amount of water, about 1/4 cup, then inflate it the rest of the way with air. 4. Light the candle and slowly lower the water-filled balloon onto the flame. What happens? The balloon doesn't pop, even as the flame touches it directly. The physics behind it. Why does water make the balloon fireproof? 3 key principles are at work. 1. Water high specific heat capacity. Water absorbs heat energy without quickly rising in temperature. The flame's energy goes into heating the water instead of the rubber. 2. Convection currents. The water inside constantly moves, distributing heat evenly and preventing hot spots. 3. Phase change priority. For the balloon to pop, heat must vaporize the water first, which requires huge energy. Until then, the rubber stays cool. Now, this same concept explains why sweating cools us. Water absorbs body heat as it evaporates. Surprising observations and applications. Here's where it gets wild. If you keep the flame in one spot long enough, the balloon will eventually pop, but not how you'd expect. The water inside boils, creating steam pressure that bursts the balloon away from the flame. This experiment isn't just a party trick. It mirrors real-world engineering. Nuclear reactors use water as a coolant. Firefighters use water's heat absorption to control blazes, and even spacecraft shields rely on materials that dissipate heat rapidly. Final conclusion and takeaway. So the next time you see a balloon, remember, with a little science, even the most fragile objects can defy expectations. The secret isn't magic. It's understanding how energy moves and how materials interact with heat. Try this experiment yourself, safely, and see if you can find other ways water's properties protect against heat. If you enjoyed this video, let us know what other everyday phenomena you'd like us to explore, and don't forget to subscribe for more fiery physics adventures. Thanks for watching, and keep experimenting.